Hi, welcome to Emerging Technology Conversations. My guest today is Michael Blumenstein, who is the new Deputy Dean of Engineering and IT at University of Technology, Sydney. And he is one of Australia's leading AI experts, working in AI for the last 25 years. Welcome.
Thank you, Debbie. Great to be here with you.
And it's great that you come up to the Gold Coast, your hometown, to come visit us. So what have you been doing for the last 25 years? How did you get into AI?
So that's a big question with a very long answer. I'll try to keep it sort of short. But I got into AI actually after finishing my bachelor degree actually here at Griffith University. And I decided, well, what should I do after my bachelor? Should I go for more study, or should I go for a job? And I really got interested in one of the academics who was talking about a project for an honours using AI. Now, back in those days, AI was not what it is today. And I think earlier you rightly pointed out that AI wasn't even used for a while, actually. It was coined as a phrase, it stopped being used as a phrase, and it came back into fashion. And as you know, now it's totally in fashion. It's like the thing. So in those days, people were doing things like expert systems and symbolic AI, and really sort of base level things, which if we looked at it now would not be the sort of technology that's supporting the advancement we're seeing. But what really then got me interested was an area that I hadn't seen before at that time, which was something called neural networks. And the whole concept so I ended up changing projects and changing supervisors. In the end, what I did was we had someone that just arrived at Griffith who just started in this new field of what's called computational intelligence, and one of the areas was neural networks within two other areas: evolutionary computing and fuzzy logic. These were three sort of pillar areas of what's called, in those days, a subset of AI in computational intelligence. And neural networks was really where everything has started for what we see AI being today. So neural networks in those days were pretty simple. In 1986, there was this algorithm developed by Rumelhart, Hinton and Williams. I don't know if you recognize one of the names, Hinton, Geoffrey Hinton, who in this day and age is being called one of the godfathers of AI.
Oh.
So he started by developing the very algorithm I studied during my honours project, and I used it for applying neural networks to recognizing handwritten characters and digits. And
so can I just ask, in layman's terms, what does neural networks do?
So neural networks are a form of what's called connectionist learning. So the big thing about AI is that AI is something that a computer does, which learns. That's it. But the other big thing is it's trained. So there are two things. You train it and it learns, and then it gives some answer. So neural networks were competing technology to that other stuff I was talking about, symbolic AI and expert systems and decision trees. In the end, what we're seeing today is that neural networks have won out, because neural networks were the only things in those days that actually could be trained. And what neural networks actually resemble are the most simplest biological counterparts of the things we have in our heads, which is the brain.
Yes.
So neural networks are based on biological neurons, but they're actually artificial neurons. So the full word terminology
so it's like branches of a tree, right? That's the way I see it in my head.
Okay, I'll define it another way. When you look at the human brain under a microscope, you've got these things called biological neurons. The neurons are actually interconnected, and they shoot electrical pulses, and each pulse then goes down another branch to go to the next neuron and so forth. Now we have 10 to the 11 of those in our brain. So you could say it's a tree structure, because they do have these little feelers that they may be perceived as branches, but at the end of the day, each of those neurons is not superly complex, but the things they do are. So they've got chemical processes, they've got electrical processes, and that's what sends messages throughout the brain. So when a neural network was created, they actually established a concept called an artificial neuron, which tried to simulate those more complex operations. So the neuron itself, if you look at it, doesn't look complex, but the processes are very complex. The artificial neuron is just really simple. It has a on and off, and that's all it does. But the big thing that's really special about a neural network, once the artificial neurons are connected, are the fact that they have weights between them. And these weights, which connect the artificial neurons, form the neural network. The weights are where all the information is stored, but it only can be stored there once training occurs, and you've got to train it on something. So data, information about, say, a scene, a character, a face, whatever it may be. And once you train enough times on those patterns, it will start outputting the correct information. So that's a very simple description.
So we're talking about, there's quite a bit of controversy with governance in AI at the moment.
Yep.
So is the training controlled, or is the computer training itself?
So the training is 100% controlled, in the sense that a researcher will say have start a training process with a neural network. And remember, I'm still describing the old neural networks here, right? So that was back in the 80s and 90s.
Yeah.
What we've got today, it's evolved into deep learning,
Yes.
which was sort of popularized in 2015, and now we've got generative AI, LLMs, large language models, and ChatGPT, which is 22, 23. So remember, this has evolved over time. But
in the last few years, it's sort of been exponential. It's been much quicker, don't you think?
Oh, this is the thing that I've noticed, and this is what I've been talking about in some of my other talks, is that the distance between when an artificial neuron was first discovered or created was 1943.
Yeah.
The first time that a neural network was used productively to solve something was in 1986. There was some stuff happening between 43 and 86, but let's say that the Rumelhart, Hinton, and Williams backpropagation algorithm, with Geoffrey Hinton as one of the godfathers of AI, he was the one that created an algorithm that actually did something, and it actually could train on things that could be used potentially commercially, but it reached a wall. The next time there was a revolution was in 2015. So if you can map that out, 43 to 86, 86 to 2015, the time by which these revolutions are happening are getting shorter and shorter.
It's almost Moore's law, isn't it?
It's looking sort of, potentially exponential there.
Yeah.
But I mean, I'm not graphed it, but I will say to you that the time frames are getting shorter. So at the end of the day, your question about governance. So people, what they're really worried about is the fact that when you formulate a neural network, the person doing it, a computer scientist, an AI expert, a data scientist, they know what the inputs need to be. They know what the outcome needs to be. They're trying to train it for a particular problem. The challenge is what's stored in those weights. So once it learns, the learning process is controlled. You can tell it when to stop learning. You can tell it how to start learning, and you can tell it what initial settings there are in the network, right? So the expert doing the training nowadays, it's not just experts doing training; it's everyone.
Anyone's
trying to do the training.
Well, I created an AI platform the other day.
See, there you go.
With AWS, one of the AWS non-coding AI.
But but that's where it's evolving to, right? So that you can actually start doing AI stuff without having to be an expert. But let's say in those days, the people who had the knowledge were the people creating it, and they certainly had the sort of guardrails around that. No one would train a neural network with data that wasn't correct, right? So if you take my simplest example of me training a network to recognize characters, so A to Z, 1 to 0, right? Or 0 to 9, whatever you want to say. I wouldn't say train in a way where I'd have more zeros in the training set than say ones, because that wouldn't make sense.
Yeah.
You need to expose it to enough different patterns to make sense. But what people are talking about today are things like bias in the data. They're talking about the fact that the weights, the connections inside the network are not. You can't look at them because they actually are meaningless if you open the file. It's just numbers. You can't actually understand what the knowledge is that's kept. So that brings to light the word black box, for example. People are thinking that it's not visible. You can't understand what's happening in there. So there are those things, but they're very well understood by the research community. They're very understood by experts in computer science. People who unfortunately not so understanding of it, they may get worried about it. They say, well, if we let this thing loose, it'll start training itself and it'll take over the world. That is
because it terminated.
There's two reasons, I think. One is people are watching too many Hollywood movies. That's number one. But of course, it's been in books. It's been decades, years.
Asimov.
There's lots of people have been thinking about this for a long time. So I don't necessarily blame that. In fact, a lot of the sort of Hollywood pictures or books have actually brought about some of the great predictions that we see. But unfortunately, some of them end in disaster for humanity, and people have latched onto that. The second thing I would strongly suggest is that education. I mean, it's really hard to say to someone now in the school curriculum, make it compulsory to learn AI. The curriculum is already bloated and full of stuff. But I remember
I don't think we should go into that right now. That's another conversation.
Yeah. Well, I just want to make one point. When I was here in Queensland, I remember talking to the then newly elected Premier, and she asked me a question. She said, do you think coding should be taught in schools? And at that time, this was decades ago now, I said, yes, I think it should, because where things have been going is that, people should understand the very technology, that some of the more details of the very technology they're using. Going back to
the basics.
Right. But by the way, that's controversial because there were other states represented in that conversation that said, we don't want to teach coding. It shouldn't be compulsory, and coding is just a fad. But I know. I was shocked. There are a lot of people to this day, right now, that think that coding should definitely not be something that is compulsorily taught in schools, and I can see that perspective. But what I'm trying to say is, whether it's coding, whether it's the basics of digital technology, something should be taught in a formal way, because you don't want to walk away from school, you don't want to walk away from universities, you don't want to walk away from any educational experience being worried about technology. That should be the last thing that you should be doing. But unfortunately, we've got a lot of people who are in different disciplines, whether it's the legal discipline, whether it's in disciplines that are not technology based, that are
they are worried. Now. They're all transitioning to technology bases. And if you look around the world, especially in Asian countries, coding, they started teaching very young.
Exactly.
So, it's not like it's not a normal occurrence.
It's not a far stretch for us to think that way. But I think for whatever reason, there are those naysayers that will say, well, there's too much to stuff into the curriculum or whatever. I think
we should take some stuff. But I'm not a happy NatLand mother. But anyway.
We should have some learnings from other countries who are actually doing it right. I mean, you've got countries that are outside of our sphere, that are making significant progress in technologies. And, I think Australia could be an amazing technology country if we focused our effort. Well,
and we're in the center of the technology boom is really happening around us. We're Southeast Asia and the Asian countries, it's just amazing. So we really should be working together. So which brings me to the one question, because I am me. Culturally.
Yes.
So what I see with different cultures is, you have a question. In one culture, the answer might be yes. In another culture, the answer might be no. So how do we differentiate, or how can we teach the computer, well, that's the answer for that group of people?
Yeah. I mean, look, that's a very good question. And I think I might use I'll preface that up front that it's a very simple answer to a complex question. But I'll give you an example. There's one of the researchers, she's a significant leader in the university that I work in right now, UTS, in data science. She's one of the top people. And she was just explaining that in the early days of doing voice and speech recognition, she remembered that she did her research and she had to train the system on some voice examples, right? But the only publicly available databases were American accents.
Yes.
Right? And so when, she tried to, get an answer from different cultural, spoken words, still English, but maybe different accents or different, it didn't work. So the thing is this, there does need to be a bit of a localized thinking about how you teach this technology. And, just as we do with our Apple iPhone or or Samsung device. If you're doing voice recognition, you've got to train it, or fingerprints. You got to train it on you, right?
Yeah.
I'm not saying every individual, but I'm saying there needs to be some element of that local understanding of context to support the technology being successful. But guess what? That requires probably human intervention.
Yes.
And so the people who are saying, look, there's a there's a worry around there being some sort of AI autonomy that's going to create havoc. The reality is that there's still a lot of human input required into making the technology good for
Yes.
all cultures, good for all settings, good for all contexts, and people are working on that, and I think we just have to be, patient with the fact that, decades ago there were only data sets from one country. Now we've got data sets and stuff from all over the world. So it's just, as I said, simple analogy, but I think it illustrates a point of how we can move forward in that space.
And so I might end on, what do you think is the future? When you think about the future of artificial intelligence, it's so expansive. The applications are enormous, but where do you think, for you, it would be best served?
Look, what's interesting is that I'm going to start negative and go really positive towards the end. A lot of people are talking about what we shouldn't use AI for, right? And that's unfortunately a mantra for a big segment. And you can see that I'm constantly referring to that because I hear it a lot.
Yes.
And it's sort of, as a person who's passionate about technology, loves AI and loves the potential of it, it sometimes gets me a little bit,
Bothered.
it bothers me a little bit. So there's all this stuff about what we shouldn't be using it for. And it's interesting, I can't remember what study, but it just got released in the new year from one of the consulting companies about what AI will be used for, in what jobs, what it won't be used for. It's like the top 4 and what the potential is. My view is the potential for where AI can be used for is in really furthering positive outcomes for humanity.
Yes.
We're talking about climate change as a threat. We're talking about the challenges we face with our environment. Guess what can solve some of those issues? I'm not saying it's going to solve it all.
Yes.
But predictive capabilities of AI, the ability for us to look at predicting or creating models to serve us about how we can understand the environment and how the changes in the climate can be appropriately viewed and analyzed so that we can have a better response. That's going to be through AI.
So you could look at all the UN Sustainable Development Goals,
yes,
and really apply it to there's 17 of them.
Pretty much.
You could pretty much apply that.
I'm not saying you do it immediately, but you could go one by one.
Yes, certainly.
And look, that's just, I think sustainability, climate, that's one area. But when you look at things like health, we're already having AI doing a better job, I'm sorry to say this, than some radiographers on detecting, cancers in mammograms, or doing a better job in detecting melanoma, and things in skin cancers and so forth. It's already beating out the clinicians.
Yeah.
That doesn't mean...
But you use it in tandem.
Totally.
You always, like I say, with people that have a fear, I'm going, well, it's a tool. At this point in time, it's a tool.
100%.
It's not going to take over. A lot of people are worried about AI taking over.
And that goes back to my earlier points, is that, that's the thing I keep hearing about. But the reality is, when it comes to health, you would not have it just go, rampant and doing its own thing. You would actually have a clinician ensuring that the prediction made by the AI is looked at. But you know what it does? It gives the clinician more time to do other things. So rather than going through every single, radio mammogram, it would actually look at only the ones that require the most attention because the AI has pointed them out. And this is, I've also demonstrated this personally, where we've actually deployed a totally different field, but you could say an environment, sort of thing, is the shark spotter technology we developed, where we deployed the drones and we had the UAV looking at spotting sharks in the ocean through video image processing, and then looking at the AI to detect the shark. But guess what? There was a lifeguard in the loop. There was a human controlling it, and the lifeguard made the final decision. So this human in the loop piece, a lot of people say, well, that's too expensive. Well, it's actually not, because where you have to make crucial decisions, whether it's health, whether it's safety on beaches, you do need that human thing, but the human doesn't have to be worried about the small stuff. Then the AI helps them to focus on the important stuff and make those very impressive decisions. So apart from sustainability and climate, apart from health, I think business is going to significantly benefit from AI. I mean, it's, you know, talking about productivity enhancement, talking about, again, taking away the administrative burden of things that people don't want to do. There are some tasks that are so repetitive that you can fall asleep doing them. You know, why would you let a human do that when sometimes they are important, but the problem is that humans need food, they need sleep, they need rest. So that's one element. But I think the biggest one, and a lot of people just don't see this, is actually ones where their life's in danger. Why would you send a human down, say, a sewerage pipe to inspect it when you could get a robot trained on AI to do it?
That's right. And I'm actually speaking to someone who's developing that next. So
that's great.
Watch out.
Well, do make sure that you incorporate in your research the work that we're doing at UTS in that space.
Yes.
So our Robotics Institute has actually deployed technology, robots with AI capability into the sewers and normal water pipes to detect their integrity and maintenance. And no one wants to be down there.
No, in a sewer? No.
But even in a pipe underground, it's
right.
health and safety. So all those examples I've given is where AI is going to benefit. So to me, it's AI for good hashtag.
Well, thank you very much, AI for good hashtag. We'll have to put that in my next post. Thank you so much for your time.
Debbie.
It's been wonderful.
It's been a pleasure.
And we'll see you in the next episode
Thank
of
you.
Emerging Tech.